Good morning, students. We're going to keep talking a little bit about the fundamental theorem of calculus today. Yesterday you looked at part one, and so I briefly want to review that, try and clarify some things. I know it's a big idea, and this is one of the really difficult parts of our circumstance right now with distance learning is um, how do we understand calculus at a deep level when we're just doing this and we're not face to face going over questions. So I'm gonna probably have to try and set up a Google Hangout here this week so we can get some clarification on this. So keep after it. Keep emailing me your questions. We'll get it figured out. But these are some pretty deep ideas. So don't fret if they're not clicking right away. So here's part one, fundamental theorem of calculus, part one. And this is what you watched yesterday in Khan Academy. And so let me just say a couple things here. The biggest thing that you have to understand in part one is that they are defining a new function called capital F of x. It's a new function. It is not this curve here, okay? That maroon curve is lowercase f of t, all right? I should properly color coordinate mine here, okay? F of x, this new function that they are defining, is the area under that curve starting at a constant a and stopping at some variable x. That's your part that can change. And obviously as that boundary changes, right, as that boundary changes, you get a different area under the curve, okay? So that's why x is your input here, okay? That's changing it. The f of t is just telling you what your upper boundary is, okay? And that's that's fixed, right? And so all that this is saying is that if you have capital F of x, which is defined as the integral from a to x of some function f of t dx, if this is a constant and can be any number, any constant, and this is a variable x, all this is, if you take the derivative of both sides, so the derivative of capital F of x is just lowercase f evaluated at x. Okay? So all you're going to do, you know, if you had the integral from 7 to x of 6t squared minus 7 over t dx, if that was it, okay, that was your f of x, capital F of x, and you were going to take the derivative of both sides. So the derivative of that is simply just substituting x in for t, like that. That is your derivative. Okay, done. Right? And you might be going, well, what's the point of that? Does that make sense? You know, like I said, I hope it makes some sense, but we don't have a lot of opportunity to really dig into that together. The biggest thing that I've learned over the years to make sense of this is, remember, derivative is just the rate of change. Okay? Derivative is just rate of change. So how much is this function changing at x? Well, think about this. Think about this little area here that's expanding just a little bit more. Just a little bit more than that. Well, that line that I just drew represents how much it changed. But look at that. That line is just that function evaluated at x. That line is just f of x. Okay? And so the amount that that area is changing is just that vertical distance f of x. All right? And so that's what you have here. I think I'm actually going to pause this video, stop it, and I'll post this first, and then I'll show you the second part here in a second.